Well, it's that time of season again. It's time for all the Black Friday sales, and this week is no exception. This week going forward through December 3rd, Bluetti is going to be having some of their best sale prices of the year, and I'm going to be placing links in the description down below. So if you're looking for a Bluetti portable power station and you want to see some of the great things they have to offer, make sure you check out the description below in the video. And because Black Friday is going on, that's the reason why Bluetti asked me to do a review on the AC300 and their new battery, the B300K. The AC300 has been out for a couple years now, and the reason why it's still in production is because they did it right the first time. One of the nice things about the AC300 here is it's a modular design, meaning there's no battery built into this top section. All of your solar and all of your power inverters are all built into just this section here. But if you have a problem with your battery, it's completely separated down here below. As time goes on and Bluetti comes out with a new battery chemistry, you'll be able to upgrade it to the next size battery and keep things going along. And if you ever had to have a warranty claim, it makes it a lot easier on shipping. It also reduces the weight. So what I'm going to be doing today is going over all the different specs, and I'm going to be testing to make sure this device actually produces everything that they say it does. If you're like me, I'm a conscious shopper and I want the best bang for the buck, and I want to make sure I'm getting my money's worth. So if that's the kind of shopper you are, you're going to enjoy today's video. So let's go ahead and get some of the basics out of the way right now. So up here on top we have the AC300. This features a 3000 watt pure sine wave inverter. The device is capable of being twinned together with another one so that you can get split phasing, which would then take your 3000 watts up to 6000 watts. This does have a peak capacity of 6000 watts, and then if you were twinned, obviously it would go to 12,000. The device does offer a total of 620 volt outlets up here that are all rated for 20 amps apiece. It also offers two 18 watt USB-A plugs here on the front, and right to the side of it we have two USB-A 3 amp plugs, and directly above it we have a 100 watt USB-C plug. The device does offer a 30 amp RV plug here on the front hand side. Now obviously 3000 watts comes out to be in 25 amps, but the plug is a 30 amp plug. We're going to be using this to test out the device here in a little bit, and I'm going to be showing you how to power your whole house with this without having to run extension cords all over. I'm going to show you some of the different options of different types of transfer switches, everything from a very simplistic switch up to the current ones that they recommend. I'll also be demonstrating how the transfer switches work. I have a total of 2 different ones that we can show you. I'm also going to be performing a lot of tests on the device. We're going to make sure that it actually produces the voltage and the amperage that it's rated for. We're going to find out how much it can handle. We're going to check it with the thermal imager, making sure that it doesn't overheat. Here on the front corner here we do have a 12 volt 30 amp plug, which does require the adapter so that you can take it to the type of plug that you want. And right beside that we have a 24 volt 10 amp plug, which looks just like a traditional 12 volt plug, so you do not want to plug a 12 volt system into that. It will definitely destroy it. However, that is a nice feature for those out there that have appliances that run on 24 volts because it's going to run a lot more efficient. And right over here on the side of the unit, we've got the main connections. Up here at top we have the 120 volt plug input, which it comes standard at a 1800 watt charge rate. This same plug here is capable of charging at up to 3000 watts, which we're going to be demonstrating that here in a little bit with the L14 plug. And directly below that AC plug is our DC input, which gives us a total of 12 volts to 150 volts DC. They do include the plug system here, which are able to plug into it and screw it on so that it doesn't come out. And what that gives you is 2 individual solar arrays. As long as you're in between that 12 volt and 150 range, you're able to have them running at 2 different voltages because they're completely separate. Now, if your solar array does go over the 150 volts that it's rated at, Bluetti does offer a device called the D300S, which allows you to drop that power down to the recommended level of under 150 volts. So that's something to keep in mind. Another option you can do with these solar panel inputs here is you can actually change it to a different type of input, such as a lead acid battery, allowing you to charge that method, or you can also do their wind turbine or EV charging. So it is capable of doing several different types of charging. One of the other interesting things it can do is not only can it charge at 3000 watts of AC power, it can also charge at 2400 watts of solar power at the same time, giving you a total input of 5400 watts, which when you have the additional batteries, which this can do up to 4 of them, that is going to help out getting you charged back up to the maximum power. Now this modular system is plugged together with the plug that you see right here. When you pull back the actual switch that unlocks it, it tells the device immediately that something's wrong. The unit will not run unless that is fully engaged all the way to the lock position, which we also have another lock position down here on this plug down on bottom. So just so you know, if you're having problems with it, make sure you check to make sure that is actually locked in. Now, like I was saying, the AC300 can be powered off a total of 4 batteries. They do have 2 inputs here for the extra batteries on the side. And the batteries themselves also have an extra input port on the side there. You're able to jump from the AC300 down to the first battery, out of the next battery down to the second battery, and then use your second input here on the top to do exactly the same thing for the other 2 batteries that you'd want to add to it. The device also does come with a 12-volt car plug here that you're able to plug it into the actual solar inputs there. It is limited to around 8.4 amps, which is going to be a very long time to charge this beast back up, but it is available. Now jumping down to the battery, because like I said, this is one of their new batteries they just came out with. Now I'm gonna go ahead and round it from 2764.8 up to 2765 just for simplicity purposes here. It is rated at 2,765 watt hours. We're gonna be testing that to see what kind of efficiency we get out of it. And another neat thing they did too is they increased the capacity out of this battery, taking it from 3,500 charge cycles up to 4,000 charge cycles. So you've gained 500 extra charge cycles with this new type of battery. The battery does offer a USB-A plug here on the very front. It is a standard USB-A at 12 watts. Nothing super fancy on that. And it is pretty simple. There's no extra buttons or anything like that to mess up. Bluetti also offers a couple other batteries that are B300 series. One's an S and one has no letter after it at all. Those batteries are available, so if you need to do charging in cold weather, the one has a heater built into it. But like I said, the big selling point here on the B300K is the fact that they were able to produce this at a lower cost and give you more lifespan out of the battery. This battery does come in at about $400 cheaper than the previous battery, even though the watt hours was just slightly lower at about 300 watt hours, but yet the efficiency out of the battery seems to be making up for that. The device does offer some fans right here on the side. If you actually was able to take a look on the inside of it, you can see that we have 2 separate panels inside there of the electronics. They have got really large fans in there which keep the noise levels down, and we're going to be testing that here in just a little bit. I was also pretty impressed with the heat dissipation that the unit does. It actually rejected heat very efficiently, and it was pretty quiet. So to shut the device off, you do long press the button there for about 3 seconds and then let off, and the device shuts off the battery and the top section at the same time. Now you're able to do the same thing in reverse. You can do it down here at the battery, hold it for a long press, and then let off, and it starts to light up the top. Just like that. Now this very final plug down here on bottom that I hadn't talked about yet is your communication plug. This is the plug that you're going to use if you do twin this with another AC300. That is going to connect one device to the other, allowing them to do split phase. You will need the fusion plug and adapter so that you can combine those together to get that 6,000 watts of continuous power. We're going to go ahead and shut it down here so that I can kind of show you how this comes apart. Like I said, you have a lock mechanism there that we're going to disengage. You push the front button there and it pulls right out. That simple. That is a pretty heavy duty plug there. The plug and the wiring stayed well within tolerances. It never got over 90 degrees even when we were pulling at maximum power. The way this separates here is you're able to pick up this top section and move it off to the side. The AC300 here is 47.5 pounds. I'm going to go ahead and put on the display the actual dimensions of it so that you can see it in metric and in standard. And coming over to our battery here, this weighs in right at 65 pounds. It is manageable, but you know, Grandma's probably not going to like it, but it is better than having to lift one of the power stations that have everything combined together that weigh well over 100 to 115 pounds. So it is manageable. One other thing here that I didn't mention, on the very top here we have 2 15 amp wireless chargers, which allow you to charge your wireless devices that are wireless. And now that we've covered some of the basics about what it has to offer, let's get into some of the testing. All right, one of the first things I want to test here is the 20 millisecond switchover speed for the actual UPS. So as you can see here, we do not have a battery in the back of the computer. I am powered purely off of the actual cord right there. As you can see right now, to prove that we're actually plugged into the wall, we are charging at around 1600 watts area. We have the power strip plugged in here. Now the voltage you can see is around 112, 113. That tends to drop when it's charging at a high rate. Not sure why. Most power stations I've seen do the same thing. So we'll see if we can actually see the blink here on the actual meter. There it is, instantly back to 120. You can see it changed. You can see the lamp on the right-hand side. Go ahead and kill the power again. You've seen a little bit of a blink. Nothing did anything there. Hit it one more time. Yep. Yeah, I was barely pushing on the switch. You've seen it click immediately. Computer did not go out. I know there's some talk about heavier running computers and stuff like that, but at 20 milliseconds, that's pretty quick and it's a lot of capacity for most normal computers, so it's a nice setup either way. So it passes that test. We have a special tool here that allows us to talk its language so that it can actually kick into the PD charging that we're going to be doing. We're going to go ahead and put it in PD charging now, and then we're going to force it to actually run. All right, we've got it prepped and ready to go at 20 volts output and 5 amps maximum current. 20 times 5 is going to be right around 100 watts. If you look over to here, you can see that we're actually, voltage is right at 20 volts. We'll start off at 30. Power station is showing 30 up top. There we go. 40, 50, 60, 70, 80, there's 90 watts. We're at 18.7 volts. Current's 4.8 amps. According to that, we are pulling 99 watts on the actual device. So in all reality, if I go too much higher here, we're going to fall below our actual max for the other devices, and then it'll shut down. You can go 1 watt at a time. There's 91. That's showing 101 up there. The biggest thing is our current can't go over 5. There's 4.9. So that's 92 watts there, and it's showing 102. So it's actually doing exactly what they said it would do. High-speed charging on USB-C, I say that's a pass. Testing the battery pack itself, it's rated for 12 watts, and we come over here to the actual tester, and we're right in there at 12 watts and at 4.8 volts and 2.4 amps. So just for giggles, we can go ahead and see how much further we can go before it kicks out. 13 watts, and she says no. I say that right there is also a pass. Now on this next test, we're going to be using a line splitter, and we're going to be using an inrush meter to see whether or not it can do over the 6,000 watts that it can do on inrush. When this saw starts up, we're going to be able to see how many watts it actually pulls on startup, and we can find out whether or not this thing's capable of doing what it's rated at. Now you're going to see this also being used at another test here in a little bit. I wanted to show you how many amps this actually pulls at startup, which you have to have a special meter to be able to do this. So we're going to turn on inrush. You can see it's at 0 right there. So let's go ahead and pull the trigger. We're at 41.4 amps. Now when I tested this earlier on regular utility, it came in at 52 amps. All right, we're going to take the 41.3 there, and we're going to take that times the voltage, which this has been averaging about 120 volts. And that is going to put us at 4,956 watts. Now, one thing I do want to mention is how these interlock really well because of the way the handle placement is. If you see the bottom of the actual power station, it has rubber feet down there, and they line up perfectly with the handles. So when it comes down, it actually locks in there really well, and it doesn't get tippy or anything like that. And just so you know, the batteries are supposed to be placed on bottom, never on top of the unit. That is in the instructions. All right, so we have the L14 charger there plugged into the actual power station. We're gonna test to see whether or not it can charge at 3,000 watts. Okay, we're gonna go into the Bluetti app here. I'm going to click on my devices. There we are connected to it. Let's go to that nut up the top corner. Advanced settings, max grid, go to pro mode, enter the password, and now we can take it up to 30 amps. For whatever reason, it did not want to work with the actual front display. Now we should be able to go back to home, and we can see we're right at 26, 27. It's climbing up. Right now we're at 2,700, almost 2,800 watts, and she's doing it no problem at all. Fan just came on. Not very loud though. Is there anything in here else we need to? Here's your silent mode. That'll actually allow you to run it down to about 10 amps. Eco mode will shut it down when the machine's not being used and the actual usage is low. Machine type, whether it's single phase or what have you, you can actually change that here. If you have 2 of them, you can change the frequency and voltages, which you better hope you know what you're doing if you're going to do that. Your alarms are in here. You can clear them and what have you. Your data, what's going on, product information, battery information, state of charge, stuff like that. It's all pretty cool. I will admit, they probably have one of the best manuals I have seen yet. Easy to read. All of the sentences are correct. Easy to read, lots of details in there, really nice. So if we come in there, we can actually see The power station's pulling about 23 amps right now. It's only going to be pulling on, I believe, one leg. Let's check the other leg here. Yeah, it's only doing this at 120 volts. So as you can see, the other leg of the 230 volt circuit is completely dead. Do not play in your electrical panel. This is dangerous, and I purposely did not show a whole lot of work being done in here just because of liabilities and such as that. I deal with people every day in my job, and I see some of the bad things that can happen when you're not real sure what you're doing. So, but like I said, you're right around 23 amps. Now, one thing I'm going to point out, this box here is wired for 230 volts, so basically using L1 and L2 of the circuitry. That may not mean something to some people out there, but basically it's wired up for 2 individual legs of power, which is your split phase. One thing I didn't mention in the original video when we're testing this out is because I wanted the flexibility of being able to power this with a 230 volt generator, this plug unfortunately is only sending out power on a neutral, a hot leg, and a ground. This plug up here did not convert L1 to L2 and power them both off of the single 120 volt phase. To plug that in, all you got to do is plug it into there, and now you should have power up here to your transfer switch. So AC power is on. I can flip that to generator. Right now, because I haven't modified my switch, only every other leg is getting power, so I'm going to end up chopping this plug off and wiring L1 and L2 together, and then this plug will only be getting plugged into 120 volt appliances, so it'll never cause a problem. It will not cause a short phase to phase. I don't know why they didn't do that in this particular plug, but you're going to need an adapter to be able to do that, or you're going to have to buy an end and actually wire it yourself. I could have always hooked the phase to phase here together in the box if this was the only device I was going to run, but I chose not to do that just so that I could run other devices that are 230 volts. And if I would have done that in the box, I would have risked the chance of possibly blowing up another device that was actually running both legs of power and would have damaged them as a dead short. So that is how easy it is to set this thing up. Just plug it in there, plug it in here, flip it to generator, you're done. You're able to monitor your actual meters here. There's nothing major on this particular box that requires a lot of power, so there's not a whole lot to show on this. Okay, now we're going to begin a static draw test. It's 9:49. We have the power station fully charged to 100%. We're going to have the DC off and the AC turned on. We're going to see how much is lost just setting in standby with the AC inverter turned on. This is going to show us how inefficient the inverter is just in standby. All right, it's been 24 hours and we are right at just about 9 o'clock. And we have dropped down to 71%. If you have a small appliance that's not pulling a lot of power, you got to take into consideration the amount of power you're losing per hour away from your battery. Everyone asks, how long will it run a refrigerator or some sort of appliance? And that's going to be all dependent upon how long the unit's turned on, just running on standby, how many things are running. So it's really hard to determine. The best thing I can say is buy yourself one of these little power devices here. It will keep track of how much power you're using. Like right now, it just kicked on, and we're pulling 173.4 watts, and it's going to keep track of it. Right now we have the power station charged up to 100%, and we're going to just run this till it goes dead. This is just a traditional refrigerator, nothing fancy. It's a little bit older one. If you have a more efficient one, then you'll be able to get a little bit more runtime out of it. Currently right now we're at 9:04, and there's our date. Let's see what we get. Coming right back in there, we're at 8:09 in the morning. We are at 8% there on our battery life, and it's still going. However, I'm going to say that we pretty much have gotten everything we're going to get out of it. We've gotten a total of about 1.6 kilowatt hours out of it. The purpose of this is to kind of illustrate that the real life usage out of these is going to be different. Grand total, we got about 23.2 hours, and I would call it easily at 24 hours of runtime on a regular refrigerator. And this being an older refrigerator, you may actually get a little bit more out of it. However, that's about 24 hours of total runtime. All right, right now we're gonna go ahead and do the total capacity test of the battery. We'll go ahead and drain it down with 2 electric heaters. We'll also test to see what kind of capacity we can get out of it as far as wattage. So we're pulling 1,357 watts on that one, and we're pulling 1,445 over here on this one. Both of them are keeping track of how many kilowatts we've got. So we're rated at 2,764 watt hours. There's always an efficiency loss when you're converting from DC to AC power. Let's see what that is. As we can see here, we are pulling 2,756 watts out of the machine at the same time. Probably not the most accurate way in the world to do it, but we're gonna find out how much noise this puts off. So let's go ahead and pull her down pretty hard at just under its full capacity, and we'll see what kind of noise we get out of the fan motor. All right, now we're testing out the sine wave to see if it's actually a clean sine wave or not. It appears right now we are right at a perfect 60 hertz sine wave. You can see our reading down here at the bottom, and you can see that our pattern here is fine. Whether we're pulling a load or not does not make a difference on it. No load, full load. Over here to the side, we also have confirmation off the meter here. We're right at 60 hertz, and even under a full load, we're running 120.9 volts. So it passes the sniff test on the actual clean power. Coming back over here to the plugs, we have the center there now at about 75 degrees on the actual plug itself. But you're gonna, anytime you have a place where it's gonna be a little resistive heat, you're gonna have a little bit of heat there. So we can see down here at the bottom right-hand side of the screen, you can see we're coming in at about 98 degrees exiting out the side of the device. As we come down to the battery, you can see down there the battery's holding in there at about 73 degrees. Nothing getting hot on it. Coming into the outside edge here, you can see that the middle of the actual power inverter is running right in at about 72 degrees. The actual cord, like I said, right there is running in at about 97. We've been running at almost peak capacity now for 28 minutes, and we're checking our SPL. We're coming in right at about 44.5 dB. That's your SPL, which is sound pressure level. All right, we just drained it completely down to zero. Now, Bluetti does not recommend doing that. It does not want you to leave it at zero for long. As a matter of fact, they really don't want you to go much below 5% according to what the manual says. So we're gonna need to plug it back in so that we can actually see how many watt hours we got out of it. So let's go ahead and do that real quick. All right, so what we got was 51, almost 52 minutes of runtime here out of the one, and we got 51 minutes out of this one. We have 1.235 kilowatts. We have 1.130 kilowatt hours. We'll go ahead and add this together and throw it on the screen right now. And when we divide that by the 2764 that the battery is rated for, we come up with this percentage mark right here. We got 1400 here, we have 1394 here. So we'll go ahead and let it run until she goes dead, and we'll see if we can improve on that 85% where we pulled it down at almost maximum capacity. You're able to see here that we did get 2,500 watts out of it. Do the math here, we'll throw that on the screen. And as you see there, we are more efficient when we pull a little bit less load out of it at one time. But there's the efficiency of the inverter under a normal load. Right around 45 dB while it's recharging, we're at 25%, and we're charging at 1,800 watts. Now you can put it in quiet mode. That is an option in your settings. You can set it for 10 amps, and that will lower down the fan speed to the point where you won't be able to hear it. Now what we're gonna go ahead and do is we're gonna turn on just the DC, and we're gonna do a DC drawdown test just to see how much power we lose when it's setting to standby. We're gonna go ahead and start the clock here at 7:46. All right, we're at 11:30 now, so we are at about 14 hours of standby time. As you can see here, we're at 95%. We lost 5% of our power just setting in standby with the DC, which is not a whole lot of power loss. So it actually did really well on that test. On our next test here, we're gonna go ahead and test this out and see if it can run a 130 volt welder. We're gonna go at the maximum amp draw there of the welder itself. This is one of those weird tests that somebody asked about on another power station, and I've kind of implemented it into the last few power stations. Sounds pretty good. Okay, let's see what the meter picked up for its minimum. The lowest it dropped down to was 117.6, still very acceptable. Next, we're going to try out a 15 amp circular saw. Okay, now it's time to eat some lunch, so we'll put a little bit of water in there. This kind of mimics a day on the job site, so we'll go ahead and hit start. We are at 100% power. Yep, you never want to run a microwave without some sort of load in there. All right, now let's go ahead and talk about how we can connect this to the home's electrical panel. We've got a couple different options that we can do with this. We can go with a transfer panel like the ProTran 2 here by Reliance. I believe Bluetti has a couple kits where you can get this included with it, but they sent me this so that I could show a couple different ways to hook it up. So if we open this up, you'll see that we have a total of 10 circuits here. It can do 120 volt or 240 volt circuits. It has a single pole double throw switch here on top, basically a transfer switch, which allows you to turn off the utility and turn it to generator safely so that you don't backfeed into the line utility voltage, possibly hurting a utility worker and also possibly damaging some things inside the home or your power station. The next option is to use an inlet box like I've got here on the side, which also includes the same type of L14 plug that we have down here on the transfer panel. But the only difference is you have to do your switching. What you do is you actually have a interlock switch here on the top. With this type of system, before you can turn on that inlet box that you see here on the side, you have to turn your main breaker off. Flipping that off, this slides up and this slides over, electrifying the whole panel here, and then you have to choose what circuit you want to use. So unless you have a very large generator or power station, you'll need to make sure that you don't overload it. So although this is cheaper, it can be a little more of a hassle for those that aren't as familiar with the system. So if you're not home and you got a babysitter there or someone else in the home that doesn't know how the system works, this can be a little more complex for them, but it is a cheaper way of doing it. And that's the reason why most people go with a transfer switch like we've got here. It does cost a little bit more, but it makes the installation very easy. It's very simple and carefree when you need to switch it over. Here at the top, you have your switch, which lets you select generator, off, or line. The line is your utility voltage. You have 2 meters here, which allows you to monitor the wattage that you're putting out. And then down below here, we have selectable breakers. These breakers protect the generator or the power station that is powering the load at that particular time. Otherwise, the breaker that's in your main panel still controls the load that's hooked up to the breaker. The transfer panel comes with a total of 6 15 amp breakers. However, the wiring is 12 gauge wire. So if you have a 20 amp circuit in the house, you are able to switch these to 20 amp circuits. Off to the left here, we have 2 240 volt outlets, which is a 20 and a 30. Then you'll need your cord for your power station. On the other side here, you have the L14 plug. This is going to plug right into your outlet here. It's going to only go one way. You'll notice that there's an L shape there. You want to find that L shape here on the panel. You want to line that up and plug it in. Once it's in all the way, you twist just a touch and it's in place. All right, that's going to wrap up our testing there. I'm going to give you my final opinions here on the device and what I think of it. This is the first time I've ever done any testing for Bluetti. I've always heard that they were pretty good equipment, and I see that they are. You know, it's got some things about it that I haven't seen before, like the rubber dust covers and stuff like that. That's something that a lot of people kind of complained about, and they just rip them off, but I have mixed feelings on it. I think as long as they're not in the way, they're great. It helps keep things out of it. Some of these connectors on the side here where they're actually screw on, it's very military looking. To keep the water out, which is kind of interesting. So, I mean, you've got a lot of money invested in this, and so whatever it takes to make it last as long as possible, I say go for it. You know, original thought when I looked at it, it seemed like it was kind of big, but you know, the more I see how it works and just the fact that even though this part on top is actually pretty good size, the 47 pounds makes it pretty easy to move around. The actual battery that's kind of small and compact on the bottom is actually the heavier part. Even at 65 pounds, that's not too bad too. I've looked at some of the sale prices. You can pick this thing up right now on the special pricing right now, somewhere right around $15.99 with the battery and the actual AC300 up on top. They do have units with the transfer switch panels, so make sure you check out them links, check out the products. Leave me a comment down below, let me know what you think about the product. Let me know if there's something else that you'd like to have seen done. You know, my channel generally is about heating, air conditioning, refrigeration, and generator repair. So reviews is not just my main thing that I do, it's just something I do because I think it's kind of fun to get involved with something a little bit different because I am related to it with the things that I do. If you guys are new here, if you would consider subscribing, if you would also hit that like button, that helps grow the channel. And other than that, guys, I really appreciate you stopping by, and until next time, we'll catch you on the next one.